In the following lessons, we will go over several designs for second-order models and how to use R to build them. Let's start with the central composite design for two factors. It comprises 4 factorial points, 3 to 5 central points, and 4 axial points or star points, totalizing 11 to 13 runs. When using alpha equal to the square root of k, the number of factors, we have the points distributed in a spherical region of interest, and for the particular case of k equal to, a rotatable design. Let's now see how to use R to generate a central composite design. In this first example, we are going to use two functions, the cube and the star, both from the RSM package. These two functions will create our central composite design in two steps. First, we are going to create a 2 in the power of 2 design with the central points, and then we are going to add the star or axial points to the design. It is the same methodology we have used in the previous lessons where we had a 2 in the power of 2 design with central points. The analysis showed a very high lack of fit. Then we added star points to create a central composite design and fit a second-order model. In the first code line, the function cube returns the 2 in the power of k design. The arguments are the number of factors k equal to 2 and the number of central points and 0 equal to 3. We are going to use randomize equal to false because it is easier to understand the design when in the standard order. However, you can delete it later. After that, we are going to add the axial or star points by using the djoin and the star function. We have more than one option for the alpha value, but we are going to use alpha spherical for this course. Please download and open the R code file SODSG, and let's jump to R and run these codes. First, we need to load the RSM package. Now let's run the first code line. To visualize the results, we can use either the print or the view function. The print function will show the design in the console, while the view function will open the design as a table. And here we have the 4 points of the factorial design, the combination of negative and positive ones, and 5 center points. However, the design only shows the coded variables. Let's add the natural ones. We are going to use the same relationship between coded and natural variables we have used in the central composite design we analyzed in the previous lesson. The relationships we have used are x1 as times minus 85 divided by 5, and x2 as temperature minus 175 divided by 5. However, we already have the columns x1 and x2. We need to create time and temperature. So we have to isolate time and temperature in the equations to create the column time as a function of x1 and the column temperature as a function of x2 in the DSG dataset. Let's run them. Now we can see our design file with the coded variables x1 and x2 and the natural variables time and temperature. As the next step, we are going to use the djoin function to add the star points to the design using alpha as spherical. Now we can see the star points as a second block in the design. They are a combination of negative and positive 1.41 and 0. The second block also have 3 central points. However, we don't have the natural variables yet. We need to run the code for the natural variables again to calculate their levels for the new design points. And finally, we have the complete central composite design for two factors with the levels of the coded and the natural variables. We just need to save it and then run the experiments. To save the design table as a CSV file, we are going to use the write CSV function. But first, let's set the folder we are going to save. To do it, first we need to choose the folder. I have Home, Dropbox, R Designs, and then set as working directory. Done. Let's save. And that's awesome. We have our newly created design saved as a CSV file. We can use either Microsoft Excel, Google Sheets, macOS Numbers to open, edit, and add results. After adding the results, we can import it again to R and analyze it.